I hope everyone can hear me. So my name is Joseph Hejderup. I'm from the Delft University of Technology in the Netherlands. So I'm a PhD student. So I spend a lot of time researching on package management and especially language package management to see how we can improve certain type of analysis. So this work is joint work with my advisor, Georgios Gousios. And I'm going to talk about our project text enough for automated dependency updating. So before going into all the results and everything, so I thought it's good to have a brief sort of introduction what I'm really referring to with respect to automated dependency updating. So first you would have, let's say, from your package registry, be it npm, Ruby gems, Cargo, etc. Whenever there is a new release of a package, services such as Renovate, dependabot, depview would create a pull request, and in your repository they will be creating a new branch. And then, depending on how you configure it, you would have basically, let's say, swap that dependency version with the new one, run the build, see if the test works, and if everything is fine, then it is accepted. So that's very briefly what I'm referring to with automated dependency updating, just so that we are all on the same page. So as a researcher, when I was looking into these services, one thing that sort of, which I find very interesting is that the main thing to test dependencies, to test automated updates is to use testing. And the main sort of premise here is that if you use your test suite, it will be able to avoid regression errors. And so that made me sort of think a little bit, because I was also looking into the literature when it comes to testing, etc., and specifically when it comes to third-party libraries. So the first sort of question that kind of came in mind is that, do we even write tests against dependencies in the first place? The second part is do project testers even cover usages of dependencies in the source code? And the third one is, are tests sufficient alone for detecting bad updates in the first place? And then also a question to the audience as well. You can tap in the room chat is, should we even write tests for dependencies and third-party libraries? And the reason why I'm also asking this question is that I kind of see third-party libraries so as ergonomic for developers, and that you can be able to use packages without thinking about too much around testing, etc., and use it as plug and play. So if you have some opinion about it, please drop a message on the room chat. I'm very curious about it, because I think in many testing papers, or in I think books in general, there isn't much discussions about testing and third-party libraries. So to sort of understand this, I conducted a setup where I wanted to sort of investigate how do, let's say, GitHub projects, it's basically how a GitHub project is prepared for using services that involve automated dependency updating. So I basically defined sort of 3 research questions. So one is, the first one is basically what is the statement coverage of function calls to dependencies. This is basically looking into how many of the calls, let's say that you have through dependencies, how many are actually covered by tests through test coverage. Then the second question is really looking into the effectiveness of tests. So depending on the severity of the regression, how well are tests actually able to detect that? And the last sort of question is that another sort of technique than using tests could be, for example, using change impact analysis. And I was kind of curious to see how that would perform instead of having tests for automated dependency updating. So how did I go about with the statement coverage? So I looked at it from 2 aspects. One, looking at direct dependencies and transitive dependencies. And for doing this, I basically extract call sites in the bytecode of Java projects. I think also I forgot to mention that I did this study on basically the Java projects and for Maven projects. And to basically looking at transitive dependencies, I can't directly sort of mine call sites, because you don't know whether a call site in a transitive dependency is actually invoked or not. So I basically build a static call graph to infer that, and then to basically measure whether a function call is executed or not, I used instrumentation, and I basically instrumented dependency function calls, and then by running the test, I'll be able to see whether those are actually invoked or not. And I use the ASM tool for that purpose, and also Vala for call graph construction. I did this over like 521 projects with like varying degrees of test coverage. And for direct dependencies, I found that the median is about 60% coverage of all dependency function calls, which means that basically half of the projects has very good coverage, basically 60 or more, and that the other half has less than that. And then when we come to transitive dependencies, the median is about 20%, which shows that only 20%, half of the projects have, let's say, like higher than 20%, and the other half has less than 20%. And I also put like a warning sign for transitive dependencies. The reasons for this is that with static call graphs, we're basically, let's say, like over approximating. So we're not, let's say, like 100% sure whether we actually like call a dependency function or not. So it's more like an indicative number. But for the direct dependencies, it is, I think, relatively sort of safe to say that it's around this way. So it clearly shows that at least for certain type of updates, depending on which function is, let's say, like not tested, there's a possibility that it might slip through the updating system. Then the next part, I think there's a typo. So it's basic to do mutation testing. And what is like mutation testing very briefly? So for example, if you have like a function add, where you do plus, let's say like your test runs fine for that. And when you do, let's say, like an arithmetic mutation, here we're swapping a plus for minus, you would expect that your test would basically be able to catch that. And then I got like the idea, well, why can't we also do this for dependencies? So I was basically using a very popular framework called PyTest. And the difference between what I'm doing and what PyTest are doing is that I am, let's say, like not mutating all functions of your project. But basically, from the previous step, I was able to know which functions were actually executed in the third-party libraries. And by basically putting mutations into those functions, I'll be able to see whether the tests are able to capture that or not. And in addition to this, I was also looking into using a change impact analysis. So this is like a very sort of quick overview. I first do like a diffing between two versions, here version 1.02, version 1.03. And I basically find out what are like the changed functions. And in the second step, I generate a call graph. I was using the CHA algorithm, which means I have like an over approximated call graph. And in the last step, I do reachability analysis. And if the change function is, let's say, like reached by the project, I consider that there is some kind of, let's say, like issue. And I then also like issue like a report, for example, that 67% of the paths are like impacted or not. And then, of course, like an interesting question is how to deal with semantic changes, because non-semantic changes is relatively easy to identify, but for semantic it's much more difficult. I basically look into, let's say, like move operations, deletion updates, etc., into the AST. But it's not, let's say, like a complete approximation. It's not that I'm able to capture, let's say, like fully new changes. And when I run the tool, this is sort of the report that you would get on GitHub. So I actually did like a study long time ago online. So basically it's like, in this case, it's an update of the React, let's say, like RX Java library from 0.4 to 0.8. And then I say like the update introduce the changes in 18 existing functions, and one of those functions are called by one function in a project, and then has the risk of potentially creating some kind of regression error. And then I basically like put there, for example, what are like the call paths and what is basically the changes that have been, let's say, like what's basically the diff. then we're looking into the test effectiveness and comparing, let's say, like both approaches. I find that, and this is also not on the same set of projects because I was not able to run the mutation analysis pipeline on the 521 projects. And on average, I found that 37% of all the artificial updates that were generated, it was able to detect it. And in most cases, it was not. On the other hand, if you would use static analysis, it would be able to detect a much higher rate. But the important thing to keep in mind is that all update cases are false negatives, so we know that they should have been detected. On the other hand, with static analysis, due to the sort of sloppy definition of the diffing, it will also have a lot of false positives. But I think the main thing here is to see that we basically don't have this like guarantees that with test it is able to detect all types of bad updates. And yes, so the question is also, is static analysis useful? So I also did like a manual investigation using my tool and basically running this on 22 dependabot PRs. When I was doing this comparison, I found basically 3 cases of unused dependencies. So in the case here, so whenever like this project would get like a dependabot PR, it would always say like a save to update, but in reality, the project was not using the dependency. And I think I didn't add it here, but I think in 2 cases it was actually confirmed that that was the case. And here, the advantage of static analysis, it would directly identify that actually those dependencies are not used because there are actually no call paths to it. I was able to prevent tree breaking updates using the static analysis tool. Only in 1 case, I was able to confirm it with the developer. And also in their case, I think their CI was not fully working or some other issues, but by running the static analysis, it was really quick to identify. But as I mentioned, that there is this problem with false positives, and that's also much more relevant when using static analysis. And one of the main reason was that most of the diffs are basically refactorings, and they didn't, let's say, like really impact the application in a negative way. And the other part was basically over-approximated call paths, and that could have been, for example, resolved by having more precise call graphs. But the issue is like when you try to build call graphs for both the project and the dependencies, it can become pretty large. So that was also the reason why I went for the CHA algorithm. So what is like my, let's say, like recommendation to toolmakers? So the first part I have is that I would sort of go for more like a hybrid approach. And with that, like, by saying that don't solely rely on tests, I mean basically that there might be cases where test is not able to cover. And I think in such cases, complementing static analysis could be a good idea. Even though, let's say, like you might not be able to detect the problem of the, let's say, like the update with respect to the diff, but giving, let's say, like more information to the, let's say, like the developer or the project team would be more, let's say, like better, I think. And then the other thing is, let's say, like more respect to the transparency. So I mean, I haven't been following too long, but I think usually on this pull request is always like a change log. I think having, for example, like insights to what I presented, like showing what are the affected call paths, what are like basically some more insight into what is actually being updated, I think would be very useful. And in addition to that, for example, like having some kind of scoring of the test suite, and also like adding, like for example, like a mutation score, etc., to show basically how effective are, let's say, like your project tests to detect these PRs. And for project teams, I think something that I've seen is like, you shouldn't blindly update, but I guess most people don't do that. I think, though, one thing that could be very interesting is to oversee tests for dependencies. And if you don't have tests, for example, you might add for key dependencies. And that is like to make sure that you don't have, let's say, like unwanted changes that are entering without you knowing. And there's also like the security aspect as well. I think so. One problem, for example, is that we might not, or we probably wouldn't, let's say, like test or logging libraries, but you never know that maybe there might be some malicious intention to plant something in like a logging library that could execute on your servers or computers. So I think it's important to kind of think in terms of, from a security perspective, what kind of changes are being, let's say, like inserted in your project over updates. I think in general, maybe not only with respect to updates, but in general, I think that's a very important point to think about. And yes, so if you want to know more, let's say, like about this study in general, there is an open access journal about this work that I did. So feel free to check it out. And yes, I'm open for questions now. I don't know if I went too fast, but yeah.
No, yeah, it was great. Thank you, Joseph. It
Okay.
was a popular talk too.
Okay.
We have a couple of questions. Is this coverage related to the use uh, of dependencies? Perhaps all use code is reached, and most of the dependency code are just not used. So I guess the short form of that is um, even if your dependencies exist in files that exist in your uh, project, say maybe not all of them are touched by the testing. Um, how uh, how would you what would be your opinion on having developers, to test for dependencies that are not necessarily touched?
That's not necessarily. So what was the question specifically in short? So like I wasn't fully following.
So is this coverage related to the use of dependencies?
Yes, exactly. So with use, basically, like when I extracted in the bytecode, I specifically extracted those function calls to dependencies. So that is what I consider as, let's say, like usage. There is, of course, for example, like when you like implement an interface from like I mean, third-party library, etc. Those cases I did not consider. So for simplicity, I only looked at, let's say, like first, the first simple way of doing code reuse, which is basically reusing functions. And that's basically how I, let's say, like considered.
So I have a follow-up question for that. Do You said that you ran your code on Java libraries. How did you instrument um, uh, testing for all the transitive dependencies?
Using Maven, I basically built a dependency tree, and from there I basically collected all the jar files that were part of the application, and then I basically use a Java agent, which uses ASM, and when you run the application or like the tests with JUnit, it basically inserts like some instructions on every function that basically records that it was invoked. Basically, yeah.
And how do you think that would work with other ecosystems like NPM, for example, which has
So
quite a
NPM
lot of
is
dependencies?
so NPM is always going to be much more trickier. I think the main, I think it would be able to, let's say, like you would be able to record, let's say, like invocations. I don't think that's like a huge problem. But the difficult part will be, for example, to implement some kind of static analysis here, like with relation to building a call graph. I think currently the way I see is that based on like latest research is to, you have, for example, like partly static analysis and you have also partly dynamic analysis. There are also like approaches that look at doing a crowdsource based like call graph building. So you basically you look at how other projects are using, let's say, like your library, and by their usage, you can, let's say, like get an idea of how your call graph is. But let's say like you wouldn't come to a point where you say like you have complete understanding of it. So I would say like this approach is like very applicable to languages that has a great type system, or where it's relatively easy to do static analysis. But in other cases, it might be a bit more trickier.
Thanks. That was actually my question. Uh, I guess I have a couple more questions. Um, so you did mention that your recommendation for project maintainers is to oversee the test for dependencies for critical um, direct dependencies. Uh, how would maintainers do that, considering that maintainers have like so little time to do anything,
Yeah, yeah,
maintain their projects anyway?
yes, I think that's like the I think the bigger problem. So I think in general, like I mean, I know it. I think that's I mean the whole point. I think with using third-party libraries that it gives you ergonomics, and you can build things much faster. Um, yeah, as I think like if it's something that is like very critical, let's say like in your application, you might be using, I don't know, like a large chunk of it, maybe 60% is like related to using this particular dependency. It's almost like as if considering this particular dependency being very important of your application. Uh, I think in that way, like it's, I think make a bit sense to write tests, but yeah, I mean, I know it's not a very easy question to answer in general. But I think it's certainly something to reflect over. Because I think
Yeah,
we very easily use dependencies without really thinking about the implications of using them in general.
yeah, that's true. Um, I think we are out of time here. So thank you so much, Joseph, for your talk. It was really interesting, um, especially for me as a project maintainer.